So hello, everyone. So wherever you are joining us from around the world, welcome to the inaugural Virtual India Energy Trade Mission Startup Showcase. I'm Abs Bulbulia, the Energy Program Director at Startupbootcamp, and I'm really pleased to be welcoming you to the Startup Showcase. We have been extremely honored to partner with Global Victoria to help reimagine what a trade mission could be in a travel-restricted world. Over the course of the last 4 months, we have redesigned the trade mission to replicate the goals and ambitions of helping Victorian companies gain in-depth exposure to trade and investment opportunities in international markets. Through workshops, connections, and the showcase today, we hope the startups will gain an in-depth understanding of market opportunities in India, explore how Victoria and India can innovate to solve shared energy problems through smart solutions, and open important corporate connections. Over the next 90 minutes, you'll hear from 8 amazing startups who are shaping the future of energy. Before we get to the showcase, I'm pleased to announce we are joined by a panel of experts from our partners in the Virtual India Energy Trade Mission and by Michelle Wade, the Commissioner of South Asia at Global Victoria. I would like to welcome Michelle up to say a few words.
Thanks, Rahim. It's wonderful to be here this afternoon, and to everyone who's joined us for this very important conclusion to Energy Startup Bootcamp and to the showcase. So as Rahim mentioned, I'm the Victorian Commissioner for the state of Victoria and normally based in Bangalore, but at the moment I'm working from Australia. And we're delighted from the Victorian government perspective to have supported Energy Startup Bootcamp since 2016. We think the potential collaborations through this sector and the ability to learn from one another and support one another's industry growths is really complementary. So we're really looking forward to hearing what comes out of this week. Over the years, we've welcomed many missions from India into Victoria, and they've been very productive. But this is our first ever energy mission from Victoria to India. And we're delighted to you Victorian and Australian companies who've chosen to explore this exciting market. Also in this new COVID world that we're all working in, this is one of our first virtual trade missions we've run. And we really think this has been a successful week. And we think this is a template to follow for future activities in India and other markets. So we're keen to hear your feedback as participants, industry partners, and of course from the organisers. So before you conclude the week, there's some points on India's energy sector that I want to make. It's been a busy week, but I just want to remind you of the scale and possibility in India and help contextualise with the partners that you've met over the past week. So as I'm sure you're aware, India was the second biggest driver of global energy consumption in 2019. Hence, it's one of the fastest growing energy markets in the world. And given its stage of development, its size and its growing demand, it will continue to be a major energy market. So well and truly a place that we should be working. According to World Bank, this is quite extraordinary to me. The per capita energy consumption in India in 2019 was 805 kilowatt hours, while in Australia, it was 10,071. So India has a lot of catching up to do and will continue to add generation capacity, both renewable and non-renewable. Government of India has exciting prospects around renewable energy and exciting ambitions, and it's got a target of installing 175 gigawatt of renewable energy capacity by 2022. This includes 100 gigawatt from solar, 60 gigawatt from wind, 10 from biopower, and 5 gigawatt from small hydropower. So a very large base of energy types to work across. And by 2030, the target for renewables is an incredible 450 gigawatt, and that will comprise 60% of the electricity generating capacity proposed in India. So as I said, I just want to touch on those points to remind you of the scale of the market that you're working in. I'd like to thank the organisers, and particularly Richard Chelm, Abdurrahim Bulbulia and Ricardo Costa, and so many others for pulling together a great program and recruiting a really good bunch of innovative startups and matching them to the needs of the Indian partners. This has been a really exciting time for us to put you together with the best industry partners in Bosch, Shell, Schneider Electric, SunPower Renewables, GE, Tata Power and L&T. They've been enthusiastic partners, and both Tata Power and GE particularly have fielded very strong teams from their sides. And we're pleased to know that many of the participants have already started ongoing conversations. I'd also like to acknowledge and thank Manoj Kohli. You heard from him a couple of days ago, I think, country head of SoftBank. Manoj is a good friend to our office. He reached out to us when he was head of SoftBank Energy, SB Energy, and that's how we got to know him. And since then, he's become the Asia Society in Melbourne's Thinker in Residence and is a long-term friend. And of course, my Global Victoria colleagues, Gopi Shankar in Bangalore and James Edward and Alex Veal in Melbourne. These programs take many, many months to pull together. And again, thank you, organisers. Really looking forward to the showcase. I can't stay for all of it this afternoon, but I'll stay for as long as I can. And thank you again for a wonderful program.
Thank you, Michelle. It's been an absolute honour and pleasure to be part of the first virtual India Energy Trade Mission. I think we look forward to many more in the future. I would like to welcome the panel. So firstly, we have Hemant Silvant from Bosch. We also have Mayur Kenny from GE Aviation, Prabhanjana Kalia from GE Research, Ritam Mitra from GE Renewables, Krishna Navalpakam from Schneider Electric, and we should also be having a role from Tata Power as well. So thank you all for being on this panel. So over the course of this week, our partners have been extremely generous with their time. Through workshops, they have introduced their companies to the startups, talked about the key challenges and pain points in the Indian energy market, and identified opportunity pathways for the startups to potentially enter the Indian market. The showcase is designed for the startups to pitch into these opportunities and for the panel to ask questions to better understand the applications and potential solutions. I'm certain the showcase will give a great window into the cutting edge innovation happening in the Victorian and more broadly the Australian energy market. So the format for today, each startup will get 8 minutes, 3 minutes to pitch their slides, and then 5 minutes for the panel to ask questions. I will have to be very strict with timing, so apologies in advance when I do cut you off. For our viewers on the website, we would love for you to get involved too. After logging in, you'll be able to submit questions, and you'll also be able to take part in a virtual investment game. Each person has $50,000 in virtual currency to invest in the startups. You can invest it all in one or split your investment over multiple startups. So please get involved, it's a lot of fun. So to kick us off, I'd like to invite Douglas Ferreira up to present. So Douglas is from Foha, and he'll be up on screen any second now. Hi, Douglas.
Hi, Abs, can you hear me?
Yes. Yeah. If you'd like to share your presentation, we'll...
Yes. Okay, so thanks, Abs. So after collecting many information from the Indian partners present here.
Hey, Douglas, just 1 second, I can't see your presentation.
Okay.
Cool, it looks good now.
Okay, good. So thanks, Abs. After this week collecting many information from our Indian partners present here, we came to the conclusion that there is a frequent power cuts is one of the major issues in India today. This is mainly caused by the inadequate infrastructure, especially at transmission and distribution levels. And as a consequence, we see losses in commercial and industrial production and damage to essential equipment. So it is estimated that 1 hour of downtime cost over $100,000 for commercial and industrial customers. So how do we solve a problem that is in front of the meter? Energy microgrids will have an essential role to do that. A microgrid can have several shapes and forms, but here essentially is a combination of a commercial facility, distributed generation, storage, and the most important piece to us, energy intelligence. That's what we do at FOHA. We develop the software solutions that provide intelligence to the system. Our product is an advanced microgrid controller connected with our one-stop shop for trading. They can operate individually as independent platforms. For example, NewGrid as a behind-the-meter microgrid, or TradeFlow has an over-the-counter energy market. But when combined, we enable a unique product. Businesses can use our trading platform to build their energy trading strategy. They can use it to do the acquisition of energy contracts and even settle their consumption with the market operator. If the customer's contract composition do not match the real consumption, we can optimize the microgrid DERs to hedge their position against the volatility of the spot market. So imagine a commercial and industrial facility facing power cuts and energy instability. We install a microgrid with no upfront cost to the customer. Our algorithms control the best time to charge the battery and discharge the energy resources, providing two main things: energy savings and earnings from the market optimization. So this way we keep lights on in case of a power outage. And when the main grid is working normally, we trade the excess of energy in the market to ensure the best return of investment for the customer. So here are my contact details to anyone keen in understanding more about us. And now I handle this over to you, Eds. Thank you.
Thank you, Douglas. So I want to open this up to the panel for questions for Douglas. So if you do have a question, please feel free to unmute yourself and ask a question. If not, I've got a fantastic question lined up already for Douglas. So Douglas, so what's your biggest challenge to implement FOHA's solution in India?
So I think one of the main challenges here is that the business model strategy that we're going to adopt in the Indian market. Usually we work in a business model called energy as a service, that in this case, we work with a few stakeholders of the energy markets. We work with the energy retailers to engage with the end consumer, but we also need investors that usually are the owners of the battery and PVs. They are the owners of the assets, and we have to make sure we are going to return their investments. And we, as a technology provider, work with other EPC partners like PV suppliers or battery suppliers to make sure we deliver a turnkey solution for the end consumer. And from this perspective, under this business model, we have to make sure we can generate savings and earnings enough to return the investment for the owner of the assets. So we see that there is a huge demand for microgrids in India, but most of this demand is still in rural areas where the customer pay low costs for energy, or even have no cost for energy. So this might be not our focus in the consumer, but for sure we know that there are commercial and industrial consumers in areas that are affected by power cuts, that might have some energy infrastructure or some energy tariffs that can be explored in a way that we can deliver the microgrid for the end consumer free of costs, but at the same time we'll have a good return of investment for the major investors.
Beautiful. Thank you, Douglas.
Hi, Douglas. Hemant here from Bosch. Why India? I mean, is it a part of your overall strategy where India comes in, or is it because of the energy issues that happen in India and you have identified India as a market?
Yeah, well, there is two main reasons that we have chosen the Indian market. The first one is because India is still a partially regulated energy market, like the market we explore very well in Brazil, for example. So we have a good expertise in these kind of markets. And the second one is that we see there is many customers in India that still suffers from power cuts. And microgrids can be a really good solution for these kind of customers, especially if they are even that they are not energy experts. We can work with stakeholders to make sure we invest the money and take the financial burden from these customers. So we make the decision easier for these customers. They just have to say yes, and they receive all the benefits of the microgrids for free. So basically, that are the two main reasons that we want to explore the Indian market.
Okay, thanks.
Beautiful. Thanks, Iman. Ritam, you've got a question as well?
Yes, I do have a question. The question is actually from some other GE experts who are listening into this. So question has two parts. The first is, do you have your own microgrid infrastructure? And how many current deployments do you have and where? If you could share some details about it or some information about it.
Yeah, so regarding the infrastructure, we work with EPC partners. So we don't have our own hardware, for example, storage or PV. For each market, we work with local EPC partners to make sure they are going to install the solar PV and the batteries. And we do the whole EPC management to make sure that our software and piece of hardware control the intelligence behind those devices. And the second part of the question is regarding the maturity stage of the platform, I would say. So the trading platform is about to become commercially available in the Brazilian market at the end of this year. So the trading platform is a bit more mature. On the other hand, the microgrid controller is still in a prototype stage. So we still have to work more on this platform to make sure it's ready to go to market. But once we have these platforms combined, then for sure we can start deploying the first pilot microgrids to test the technology. So this is an interesting question because we see a few partners here that mentioned about IP sharing and also open innovation possibilities with startups. And this is the kind of partnerships we are looking for. We want to work with major corporations that are willing to test this technology with us in the field, and that also want to share the IP to explore in the future.
Excellent. So we just run out of time. I know, Krishna, you've had a question, but maybe we'll follow that question up after this. So Douglas, thank you for your time. And next up, we've got Mike Harris from Next Technologies.
Hello, and thanks, Abs, and thank you, everybody. I'll just try and share my screen. Seems like you took over my screen then, Abs. Hopefully this will work. Is that working?
Just once, it looks like it's sharing, but I'm just getting a black screen at the moment. There you go, it works. Yeah.
You can see it now?
Yeah. I can also see some text at the bottom.
It's just, I can turn that off if you like. It's just because I speak fast, I always put captions on.
Cool. Off you go.
So thank you, and thank you everybody for taking the time to listen to us. I guess the first thing we need to do is think about what is the problem that we're trying to solve. And we believe that the world has a lot of knowledge and wisdom, but that's leaving all companies, not just energy companies, in droves, we would say, particularly as employees move on. Modern companies are data rich, but they're information poor. They're not getting the opportunity to convert that data into information. And often we find that employees don't follow procedures. So even if there is the information, they don't follow it. Much of the knowledge and the wisdom is contained in the data that those companies have, but they're not in a position to make good use of it. So how do we gather and share that knowledge and wisdom? And in fact, is there even a solution? Well, yes, there is. Modern technologies allow for learning, and they allow systems to comprehend the data that's contained. And that allows the systems to become wise. They gather the wisdom that the company has been able to build over the years of operation and the multiple employees that have been there and built on that data and therefore that wisdom. So what we're looking to create is a digital employee who becomes the oracle of all that important company data. They know all there is to know that's possibly available for maintenance in particular, that's in the company's data, and who also knows the procedures and insists on following them. And this digital colleague works alongside all of your other employees, sharing the wisdom happily as required and in the employee's own natural language. So why now? Well, because the technologies and the infrastructure are only now truly available. It's the cloud that's developed that's allowing us now to use these technologies. And of course, an aging population means that wisdom is leaving in droves. As people retire or move to other jobs, they take all of that knowledge and wisdom with them. And the newer employees that are coming in, they're the tech-ready generation. They're the Google generation, and that's what they want to use, is the types of search engines that are like Google. And in the age of disruption, Lex is genuinely disruptive. So we've got some great success stories, both in the energy sector and in the aviation sector in particular, are the two big success stories that we're able to share. And we think that there's some great stories to be shared from those if you become interested in them. And on that note, I'll say thank you and open it up to questions.
Thank you, Mike. So I'm going to open this up to the panelists for any questions. So if you do have a question, feel free to shout out.
Sure. Hey, this is Prabhanjana from GE Gas Power. So Mike, I have a slightly different question, mostly from Maintenance 4.0 that is there on your website, and that was what one of our experts was interested in, and more importantly, from a cyber physical systems perspective. I was just wondering if you can throw a little bit more light on that.
So when we talk about the cyber physical systems, of course, deep down, we're talking about the underlying infrastructure, whether that be networks or servers, cloud infrastructure. And sometimes we might even be talking about Internet of Things devices. So in other words, any of the underlying physical systems that will support the maintenance 4.0 and the likes of Lex or other platforms going forward.
Okay, and are there any aspects about the security problems that you're solving through the CPS, using CPS?
We haven't seen any security problems, and security's been very easy to handle. The system can sit on anyone's cloud, so it can be internal to the companies if they're worried about data security. We just put it on their own cloud, and of course it can be hosted externally as well. It's entirely up to the implementation team how that's managed.
Okay, thank you.
Hey, hi, Mike. This is Mayur from Aviation team. Thanks for the presentation.
My pleasure.
I have a question. You spoke about capturing the information that is there within the employees, the written records and all. What sort of, where would you say you are on that technology journey in terms of being able to get that information automated, and how do you account for the variations that exist between languages, cultures, people across the world, and what's that going to take to develop?
It's a great question, and it allows me to tell you where I think Lex becomes particularly unique. So it can gather the data from anywhere, whether that's an existing digital source, so can scrape the data from any of the engineering and maintenance systems, Trax, CMRO, Rocade, AMOS, any of those systems can be scraped in, as can handwritten data can be scanned, and the handwritten materials can be ingested as well. The system also ingests all of the manuals, all of the manufacturers' manuals, regulatory manuals, companies' own manuals, can ingest all of that, comprehend and understand it, and learn from that data. And that's its true strength, in our opinion. So language, because it's machine learning, one of the great features is we all know that aviation is an English-based industry, but many of the people who work in aviation, it's not their first language. The beaut thing about Lex is that it allows them to communicate with Lex in their own language, but Lex will go and collect and store the data in English so that both sides of the equation are handled nicely.
Thank you.
Thanks, Mayur. We've got a couple of minutes if anyone's got another question for Mike.
Look, I can ask one more if that's okay.
Please, Mayur, go for it.
Okay. Your website kind of talks about image processing as well as artificial intelligence of it. How is that working in terms, because a lot of these images are through, the customer data, because they capture it through boroscopes and things like that. What level would you say you're able to, detect what we're looking at? Because as you know, in an MRO industry, it's pretty difficult to identify what part we're looking at. Yeah. So is the software capable of doing, and where would you say you are on that learning curve?
Because the system is a learning system, it's entirely dependent on existing data. And one of the things we're finding with the images is, of all the data that's available in aviation, images, there's not a great deal there. Although, as you say, boroscopes have been around for a while, but taking images, whether that's using remote vehicles or just cameras, that hasn't been so popular to date. So there hasn't been as much data to work from. Having said that, we're working really hard with some partners to make sure that we do start to collect that, and then we will be able to work with the images. And we see a world where Lex will be able to start predicting what damage might change to over time based on its learning from previous images.
Okay, thank you.
Thank you, Mike. Thank you for your time. Next up, we've got Doug Hart from Hart Energy. So Doug's doing some amazing stuff in the bioenergy space, so he'll be joining us in a second. Hello there, Doug.
Hi, guys. Thank you all for joining us today from India and from Victoria and from wherever you might be in between. I'm Doug Hartman from Hart Bioenergy. We're the builders of the Hart Biomax anaerobic digestion biogas systems. Bit of a mouthful, but the Hart Biomax for short. We're attacking two of the biggest problems in the world that we see, including soil degradation and a shift away from fossil fuels, including coal, other diesel, and other petrol products. We see a case for...
Just to interject for a second, if you want to share your screen, I'm not sure we're seeing your screen share.
Okay. I'm not sure why that's not coming up. Hang on one sec. Sorry, guys. Try it. There we go. All right. Is that coming through, Abs?
Yes, that's coming through.
Okay. All right. Sorry, guys. There we go. All right. Tech issues. It's all right. Melbourne at 5 o'clock becomes a bit of a jam here, so do apologize.
If you do have any issues, just let me know and I can share your presentation.
Okay, yeah. If you want to pop that up, it's probably easier at your end. I might do a stop share. Thanks, Abs. All right, so on to the next slide. Thanks. So we see the problem, and the solution is that bioenergy in a distributed form and the creation of biofertilizers from organic material. So we see bioenergy as a nice fit with solar, wind, other renewables, obviously, and hydro, geothermal, and the kind of underrated aspect of renewable energy and generation. There's been some challenges in the small scale development, so we've tackled that, and we think we've come up with a bit of a solution for that in our product. Pop the next slide, please. So we've developed the Hart Biomax AD system. It's a containerized unit, small scale pocket digestion that can be implemented in just about any environment, urban or rural areas. connects easily with microgrids or existing large-scale grids, can be flexible in its energy delivery. So we can set up the system for whatever the demand is locally, whether that's electricity production, hot water, refrigeration, and carbon capture, which we think is going to be, leading into a lot of things with renewable fuels, artificial photosynthesis, and as well chemical production, biochemical production, hydrogen, and through SMR. So we're experimenting with some of those. On the right-hand side, you'll see we've got a reference plant that we built, and that's our pilot commercial scale. And we're testing out all the different pieces that we build, but the main heart of the system is a much more efficient system that is smart enabled, connects easily to the existing infrastructure. For operators, it's very hands-off operation. Most all the processes are automated, so making it ideal for rural and remote communities where access to service may be a bit of a challenge, as well connecting into that digital infrastructure that India is building at the moment. If you want to pop the next slide, please. So our team is myself. We've got a team of engineers, strategy, plant scientists, our electrical engineer, and we are at a stage where we're ready to scale up. We're looking for partnerships in the Indian market to connect in and do a demonstration of what bioenergy at a small scale, at a flexible scale can do. On a microgrid particularly would be great way to showcase what we're doing. We think that the opportunities for energy storage in the form of gas storage, will play an important role in minimizing the cost for energy storage, and that flexible approach to on-demand energy, and that demand response as well. So that's kind of the space that we're playing in. We'd love to connect with anyone who's interested in teaming up with existing microgrids and other renewable technology. Thank you very much. Thanks, Abs.
Thanks. So I'm going to open this up to questions from the panel. So if you do have a question for Doug, please jump in.
Hey, Doug, this is Prabhanjana from GE Gas Power. I just had a quick question, actually two. The first question is, so far, what is the rated flow of biogas that you have been able to generate from your system, right? And what's the rated flow and pressure, which is something critical for the energy generation as well. The other aspect I wanted to ask is, the reference plant that you mentioned, what is the engine that you're using there? What kind of engine are you using?
So currently we're using a Yanmar cogen that's built for biogas. We're pretty agnostic when it comes to the energy generation side. We are looking at options to build our own, or partner with somebody who's looking to get into that market. We've experimented with micro turbines. There's a whole range of very flexible solutions, all the way down to 3 kilowatt turbines, super micro turbines that are capable of running the biogas in a fairly raw state. Some filtering around hydrogen sulfides, obviously, dehydration, but otherwise they're pretty capable. All the way up. So the engine we chose was because we can actually scale that up to 200 kilowatts. They can stack easily. A lot of the micro turbines coming on the market as well are similar in their capabilities of having that shifting, so we can run one engine at low demand times and switch on up to 8 engines, as needed. So that's pretty crucial, I think, when you look at a picture where you've got variable demand, and remote communities on a microgrid, for example, that may need that bit more flexibility. And for maintenance, it makes sense if we lose an engine or one goes down for any reason, we're not out of commission. Gas flow, we've designed that one to run about minimum of 25 cubic meters an hour, and we can size that up easily. We have our own pump designs for boosting pressure, but it's all still fairly low pressure requirement. So it's designed for a low parasitic loss.
Beautiful. Thanks, Doug. We've got a couple of minutes, so any other questions from the panel? I've got one for you, Doug. So what are some of the applications for your product?
So agriculture is obviously a big one here in Australia and other areas, but we see the urban market as prime for us, where we can connect in and deal with food waste. The last report I saw, India is facing a similar challenge around food waste. So we can actually convert that much higher energy, potential. So we're looking at integration into buildings directly, campuses, universities. So we think there's a pretty wide suite. We're working with food processors at the moment, so where they have that waste stream, that needs to be cleaned up before their water goes in anyways. They've got a compliance issue. We can do, two things: reduce their energy load, especially if they've got heat or hot water demand, and that cleaning element and electricity or refrigeration at the same time. So it's we see kind of a very broad range of applications for the technology.
Beautiful. Thank you, Doug, and thanks for the panel for the questions as well.
Thank you.
Next up, we've got Nick from WePower. So, Nick, when you're ready, if you want to share your screen. And you're on mute as well, Nick.
Yes. Hello, everyone. Yeah, 1 second. I'll share my screen in a sec. I hope that works.
Yeah, it looks good. Looks good.
Awesome. So, hello, everyone. My name is Nikolai Martinuk. I'm co-founder and CEO of WePower. WePower goal is to facilitate energy transactions of any size directly with the producers and maximize the practical value of sustainable energy. So 2/3 of energy globally is being consumed by commercial industrial clients. And that is where most of the impact could be found today. The energy system is changing with more renewables getting connected to the grid, but the way we buy and trade energy is not. We believe that sustainable energy procurement can be optimized for better results. And if corporate and industrial customers have an opportunity to buy local and sustainable energy at a market price, companies will do it every time. However, this option is unavailable in most markets today. We're connecting energy market participants in a meaningful way to enable direct energy transactions and provide a radically simplified energy procurement experience for all market participants, providing never seen before flexibility and the easiest way to discover, choose, and sign source transparent energy contracts. Through WePower ecosystem, we offer 3 main products. First of all, platform as a service solution Elemental, providing utility retailer type client with a full lead to deal platform as a service, which is currently deployed with 2 retailers in Australia, enabling them to rapidly develop and offer new sustainable energy offerings while providing amazing experience to corporate and industrial customers. We also work directly with SMEs to medium scale corporate industrial customers through Energy Control Center, providing them the tools to track energy portfolio they already have and easily procure additional renewable energy from the marketplace, while getting all the additional services they might require from the retailers that are offering their services through our platform today. Last but not least, our wholesale marketplace for power purchase agreements allows larger corporate energy users to secure direct contracts with renewable energy producers through a standardized and streamlined process. And platform participating retailers are able to secure additional renewable energy capacities that could be offered to the buyers seeking to purchase sustainable energy through the secondary marketplace, eliminating barriers for everyone to maximize the value of sustainable energy. We have an ever-growing pool of green energy available for direct procurement in Australia, across Queensland, New South Wales, Victoria, and Southern Australia, with over 1 gigawatt of capacity available for sale over the next 2 to 3 years, as well as a pool of corporate and industrial customers with over 1 terawatt hour of annual demand. We have 2 V-Power platform as a service deployments in Australia, providing an end-to-end utility scale platform with a combined portfolio of 13 terawatt hours per annum. We're currently entering European and other markets and looking for innovative retailers and partners looking to rapidly launch and test new cost-effective local sustainable product offerings. We are a team of more than 15 energy market experts with unique experience working in finance, energy, and digital transformation. We're headquartered in Lithuania and with commercial office in Australia, with experience of successfully delivering large-scale digital energy systems and customer-facing products. Thank you.
Thanks, Nick. I want to open this up to the panel for any questions that you may have for Nick. Please jump in. No one wants to hear my voice for the rest of this panel discussion. So if you have a question, please ask one.
Hi, this is Rhythm from GE Renewable Energy. So I see that most of the organizations that you work with are power producers, IPPs. In your experience, have you worked with any OEMs? So say GE Renewable Energy as an OEM, how do you see any partnership with companies like GE or others?
Yeah, it's a good question. So we haven't actually worked with OEM directly. It's a question we see first of all, we start with where we can see the immediate result can be achieved. So we started with the larger corporates, SMEs, as well as retailers that are using the technology to work with their customers directly. We're currently working also with IPPs, as you mentioned, those that are developing their renewable energy projects to be able to sell them to the customers. We had some interest on expanding that offering to encompass additional data that is coming from the installed equipment on site. So far, we haven't done that in Australia, but we see that in our scope at the later stages as well. We haven't worked with GE Renewables much, but we've also worked with other companies that see that let's say area expanding over the next couple of years to include that information on the platform.
Cool. Thanks, Ritam. Krishna, you've got a question?
Yep. So Nikolai, very good presentation, very well done, and you articulated the value proposition very well. In one of your slides on the 3 models that you explained, right? So with retailers and utilities, with small, medium businesses, and the transaction marketplace, particularly when it comes to the Indian market, have you figured out to start with which of those 3 models are possibly allowed in the competitive and regulatory environment in the Indian market? Any thoughts there?
Yeah, thanks for the question. So generally, and for historical reasons in Australia, we started with a PPA marketplace first. That was the where we saw the immediate result. But again, for the international expansion and the way we see expanding to other markets, we generally start with either the offering to the retailers as a core partner in the very beginning to grow from there, which brings essentially immediate results to utility to engage their customers in a better way and create an internal marketplace for them within the company to do it first, or with a core buyer. So that's the second one. Depending on which goes faster in that specific market, we choose that way to start the engagement in the market. So if, for example, we have a larger customer, because the system allows quite sophisticated procurement to happen on the platform. You can group different assets. You can do the procurement across multiple countries, and for example, in Australia, across multiple states. So if you have we have a a core buyer that would like to explore that and to manage basically all the contracts that they have in one single place, that's the way we would start with them in that specific market.
Clear. Thanks.
Beautiful. Thanks, Nick. We're going to have to move to the next startup, but great presentation, great Q&A. Thanks, Nick.
Thank you. Thank you, everyone.
So next up, we've got John Coates from Electrons. So John will be joining us on screen any second now. John, hopefully you can hear us. Switch your camera and your microphone on. Great. Excellent, I can see your screen share as well. If you're not going to present mode, that'd be perfect. You're on mute, by the way, John.
Okay, so now go back to present mode.
Yeah, you're
so
good.
Can everyone see that presentation and hear me?
Yes.
Fantastic. Okay, thank you very much.
So we can't view your camera's off, by the way.
The camera's off as well?
Yeah.
You want to do that? Can you see me now?
Yeah.
Fantastic. Okay. First of all, thank you very much, Krishna, yesterday. Great presentation from yourself to give us a good context. So, you know, I think you need a little bit of recognition. Thank you very much for the thumbs up there. But, you know, innovation at the edge, ideas into growth. Fantastic. So I'm here representing Electrons, which I'll just start off with the fundamental problem statement. It's the voltage problem. With the audience that we have here, I think we all understand that electrical grids designed to deliver power one way. And once we have the situation when we have distributed energy resources, creating that power and feeding them back in, we've got problems that can arise. And then what we're seeing in different markets at different places. Excess generation, we've got too high voltage. Excess demand, low voltage. So how do we actually address those issues? Now, there's a number of different ways that we can do that. You know, we can talk about infrastructure side, we can do all sorts of things. However, what we've got is Electrons, which is a combination of hardware and software. I need to make that clear. So it's hardware and software. Now that can connect solar with or without batteries to a grid. So what this is a rack mountable piece of hardware, 35 kilograms, which would effectively replace approximately a ton worth of equipment with various different software functionality. Right now, there are many different things in here and the competitors that can do bits and pieces, and I'm not going to go through each one of these features, just going to work on the ability to increase hosting capacity. So what we've got is a device that will monitor voltage and frequency in real time and using software, and internally there's this silicon carbide and some firmware and hardware and software runs, and we'll monitor that voltage and frequency in real time and adjust accordingly, such that you will never be outside of the regulatory limits or the operational limits, depending on which sort of country or operational context that you're in. So, you know, so what does that mean? Now, this can operate in front of the meter or behind the meter. We'll concentrate on behind the meter for today. So at the moment, we may have a situation where we're connected and we may have a smart inverter, but once we get outside of an operational limit, that will cut off. Electrons will always stay on. And what we mean by that, and that will operate 24/7, not just when it's happening. So what we can do is unlock quite a lot of opportunities from sort of beyond that. So to give you an example of how addressing this fundamental voltage and frequency problem is IKEA or IKEA, depending on where you're coming from. Now that's in South Australia. Now I'm not sure if on the right-hand side of the screen you can see that with the operational limits that we've got within the saturated grid in South Australia, we could only do a 600 kilowatt system with no batteries because of the fundamental problems of connecting to the grid. But by putting the Electrons technology in, we can solve that problem such that there is never curtailment. So we've now gone from 600 kilowatts to 1.2 megawatts, and we've also got the ability. But what it is also doing is providing functionality to the grid, which is usually a grid investment side scenario, which is, say, the Tesla mega battery that we know about down there with those 90 megawatt hours. So for zero cost to the grid, a customer is realizing benefits such that they can maximize solar, they can put storage in. In this case, we can do arbitrage and things like that. By fundamentally fixing this voltage and frequency problem, we've got a lot of things that we can unlock. So the numbers that we want to look at here is, instead of looking at around about a 20% hosting capacity of solar, we can increase that to about 200%. And that's the thermal capacity of that distribution transformer on a low voltage network. So there's a lot we can do, and just want to reiterate that it's hardware and software. We turn things on and off without batteries. This is 24/7. This is not just a daytime sort of solution. So the opportunities in India, if we were looking at this side here, is effectively, I think just today, we just want to grow on hosting capacity based on where India is today and in its growth. So instead of large scale infrastructure investments, that innovation sitting at the edge, we can increase hosting capacity significantly with zero cost or zero spent on the infrastructure side. So all these other ones, we can do microgrids as a service. It is 4-phase if we've got engineers on the line, such that we can do those types of things, but I'll stay away from that application today. The other thing is that, back to Krishna's words the other day, which was, proof of concept, pilot, and then to scale. I just want to sort of highlight here that we do have IKEA as this reference case. So we have gone to that stage just so we understand that, this is not sort of a new solution sort of sitting on the market. At that particular point, I think I've reached approximately my 3-minute limit. Would that be correct, Abs?
You have. So I'm going to switch it over to the panelists for their Q&A.
Fantastic.
If you've got any questions for John?
Hi.
Yeah.
This is Ritam here. I have a question from one of my GE colleagues. So can you share in which geographies do you have your customers today?
Customers today are Australia. It's an Australian company with Australian customers as part of our growth strategy. We will be taking it to other markets. We have 3 representatives in the 3 markets. I'm in Singapore now to take this technology to Asia Pacific. We have someone that is now in North America, and we have someone that is the United Kingdom. We're currently going through some expansion plans there. So this is the beginning of our global expansion. Customers, Australia.
Okay, thank you.
Thanks, Ritam.
We can ask a question. This is Arul.
Yes, Arul.
Can you explain? I'm still not
good presentation, John. Quick question from me.
So I've got a rule on for first.
A rule from Tata, yeah.
Yeah. Oh yeah. Hi. So I just want to understand how you. I didn't understand how you help Nokia. You said 20 times the capacity of solar. Can you explain that in more detail? How you facilitate that larger? Just because you have the battery, you can that.
So
and
when you have
the voltage, how the voltage and frequency problems were addressed, or what was limiting? I didn't quite get that.
Okay, so on a low voltage grid, you'll have a distribution transformer feeding power one way. Now, that's the way the grid has been designed. As soon as we start adding on additional distributed resources feeding power back in, the grid is not designed to do that. So we will get excess spikes in voltage. All right, so one system, 2 system putting power back in, we don't have problems. But if we have multiple systems getting to a particular saturation level, we will get to the point where voltage spikes are seen and you have problems caused on the network. At that stage, if those problems exist, you will not be allowed to connect to the grid if you want to put a solar system on, or you will be limited to zero export. But effectively, it's the voltage increase and frequency instability that is created by additional solar ingestion points. Does that answer the question?
Okay, got it.
Beautiful.
Yeah, fantastic.
So I'm just conscious that Himath, you have a quick question and a quick answer.
Yeah.
One, please.
Very quick one. So I saw battery as a service. So are you already offering it somewhere in for automotive applications?
So you're breaking up there, Hemant, sorry.
So I think the question was around battery as a service for the automotive. Is that correct?
So battery as a service, have you offered it anywhere for any automotive applications?
So nothing for automotive applications as yet, but it can be done. We have looked at but no.
Okay, but is it the battery swapping technology that you're looking at? Or it's
so we are the hardware device that connects to the grid. So batteries can be included, and we are working with multiple battery providers.
Okay.
And within the software, we can work with all different types of batteries such that we can optimize those battery operations, being charge, discharge, energy arbitrage, etc. Krishna, I see you. And
a quick comment and feedback, not a question. You looked at utility, stationary storage, CNI, and off-grid clearly. Look at the data center, cloud data center, hyper data scale data center use case very strongly.
Correct. Absolutely.
Good luck.
I hear you 100%. Kept this presentation to a particular use case, but yes, 100% with you, Krishna.
Cool. Maybe it's a good idea to have a conversation post this. So thank you, John, and thank you to the panelists as well. Next up, we have Stefan from Inverted Power. So we can see your screen, Stefan. I'm just...
Can you see me?
As well. Yes.
Hi, everyone. Welcome. My name's Stefan Smolines from Inverted Power. Today, I want to talk about convergence of two megatrends. One is the electrification of transport, and the other is the trend towards decentralized renewable energy generation. So at Inverted Power, we believe we can sort of solve both these megatrends with one solution. There's many reasons why you'd want to do that. The first is to avoid duplication of assets. It's very similar hardware requirements for each of these megatrends. The second thing is to improve the utilization of the asset. So now from the same asset, we have two potential revenue streams. One could be selling primary and secondary market services, and the second one could be selling energy or charging as a service to electric vehicles. The third is there's a lot of synergies between these hardwares or applications. So if we take the example of an EV fast charger, the integration of solar and on-site storage can reduce our peak demand charges, it can reduce the capacity requirements, and it can lower our operational costs. So how is Inverted Power involved in this future? Well, our mandate is to really reduce the cost of infrastructure. We believe with an improved business case, that being two revenue streams from the same asset, plus reducing the cost of the asset up front, if we can then have much higher and faster deployment of these assets and then bring around this megatrend faster. So we do this through two technologies. The first one is jumping on the bandwagon of Generation 3 vehicles, which are going to be included with a onboard DC to DC fast charger. Our particular technology integrates this functionality into the traction drive, and we can effectively do that for free because every electric vehicle already has high power electronics in terms of the traction drive, and the operation between driving and charging are mutually exclusive. So our technology can unlock this feature to have a high powered onboard DC charger. And then the second technology is then exploiting that onboard DC charger of Generation 3 vehicles so that we can eliminate a lot of the cost and complexity and size out of the charging infrastructure so that it becomes effectively an order of magnitude cheaper. And then if we have it, infrastructure which is 10 times cheaper, our hope is that we can have 10 times more of it. So how does that play out for the members of this panel? I've tried to include everyone here. If we start with a Shell service station as the basis of this, centered around maybe a large on-site storage of a battery, some on-site renewables as well, which are intermittent and being sort of stored in that battery pack. Then the service station only needs a DC distribution across the service station with DC EVSE. So very similar to an AC EVSE, EVSE meaning electric vehicle supply equipment. It only includes communication and contactors and fusing, that sort of thing. So there's no power electronics required. the power electronics are on board the vehicle in the DC to DC converter. So in this case, a traction drive by Bosch, e-axle with 90 kilowatt onboard DC charger. So if we look at each service station as a bit of a, it's got its storage, it's got micro generation, it's a distributed energy resource with a bidirectional grid connection. We can aggregate these into a virtual power plant. So in India, there's 60,000 service stations. If we take this model, that would translate to a 60 gigawatt dispatchable asset on the grid. So again, you get these 60,000 distributed energy resources and 60,000 charging locations for EVs. So you can bring about both those mega trends with this one solution. I'll leave some references up here on the screen, but happy to take any questions you might have. Thank you.
Stefan, beautiful. Thank you. I'm going to open this up to the panel for any questions. Got a question? Feel free to jump in. I see Hemant, you probably have a question. See you coming in.
No questions from my side at this point.
So maybe I'll kick off with my question. So are there any examples where this type of technology has been used before?
Yeah, so commercial vehicle operators already use this type of technology. They're in a unique position where they buy both the vehicle and the infrastructure, so they can already optimize their solution today. It's a little bit harder with passenger vehicles because you require mass market vehicles to have this onboard DC charger. But as I mentioned, that's coming. So at the moment, it's just the Porsche Taycan, which is the first generation 3 vehicle that has a 150 kilowatt onboard DC charger. So you could deploy this already today with Porsche. But coming from next year, Hyundai, Kia, all the Ionity members in Europe, they'll all be coming out with generation 3 vehicles. So this is definitely going to become mass market. So this future can definitely take place.
Hi, this is Arun.
Oh, I have a question. Sorry, go ahead.
When you distribute the chargers in the vehicles, is it the overall cost increase because every vehicle has a charger rather than a one public charging station from an ecosystem perspective, not just the vehicle perspective?
No, that's a good point, and that's what was our first technology that I highlighted. We actually use the traction drive, which every electric vehicle already has. We're using that as the charging system. So we're not actually adding any cost to the vehicle. We're just unlocking this feature. It's a slight sort of architecture tweak in terms of a high voltage wiring layout, and the rest is software. So the cost of the vehicle is actually negligible. But thank you for the question.
Okay, so apart from the Porsche, where you said you're looking at it, which other OEs have you already discussed this with? Because you had put up data, was it more of an illustration or is it already done?
I mean, I'm limited in what I can say, but I can say that pretty much every OEM that I'm aware of and tier 1 are looking at integrated charging topologies. You can find that out from the patent landscapes. We're in conversation with quite a number of them because, as I mentioned, there's a requirement that next generation EVs to have this onboard DC charger. So it's coming. And it's basically because at the moment we've progressed so far away from the original EV charging standards from 20 years ago. Technology's progressed, and now those standards are basically holding back development. So this onboard DC charger is sort of circumvents that problem.
And what's your business model here?
We license our IP. So we have a number of patents, including in India, for methods for the integrated DC charger into the traction drive. We have one of the earliest priority dates compared to sort of the competitive landscape. We don't intend to produce any hardware, but we would work with tier 1s or OEMs to help them integrate this technology. So we provide reference designs. We have prototypes that we can provide for testing and stuff, but yeah, we wouldn't be providing any end hardware to the customer.
Okay.
Thank you.
Okay, thanks.
Cool. Thanks, Stefan. Next up, we've got Sundar Iyer from DS Power Sensor. So let's just get Sundar up on screen. So Sundar's our penultimate presenter. So big pressure, Sundar. getting Sundar to come up on screen. So as Sundar comes up, I think especially with inverted power sensor, so inverted power, I think there's some really amazing potential applications in that space for India. Sundar, welcome. If you could unmute yourself and also share your screen.
Wonderful. Hopefully you can see my screen and can hear me loud and clear.
Sounds great. Thank you.
Wonderful. Yep. So namaste and good day, everyone. My name is Sundar Iyer. I'm the General Manager of Energy Products and Markets here at DS. And today I'd like to showcase the power sensor to you. The DS power sensor is a low-cost, do-it-yourself approach to obtaining holistic energy insights in real time. And those insights can be for both energy efficiency as well as energy empowerment. So I'd like to start with a quote here by Dr. Shivaram, and which really underscores the need for end user energy engagement. He's pointed out that the forecasted demand just for air conditioning alone is equivalent to 70% of the whole of Europe's total power system capacity. And that's really quite incredible. And I think in addition to that, we've got a lot of perspectives from the week that's just been from Arul, from Krishna, from Anuradha, and from Hemant, from these organizations and their respective teams. And really thank you for that. So we've heard from them, and we understand that there is actually a very good match there between your needs and our capabilities. What we're also hearing is that, like in Australia, India's distributed energy future is very much being driven by end users as much as it is being driven by industry participants. And everyone is seeking more efficiency, more empowerment, but we feel that this cannot happen without visibility and engagement. End users, residential, commercial, industrial, all have questions around costs, ROI, return on investment, safety and assurance of supply. And similarly, on the provider side, there's questions around resiliency, affordability, security, and of course, everyone's keen to profitably help their customers. These are hard questions. Until now, there have been no easy answers. So enter the power sensor. The power sensor bridges the visibility gap between those end users and the providers, regardless of their meter or inverter. And we feel it's the simplest way to see the energy used or generated. So there's no wiring, there's no tool, there's no electrician, there's no disruption of supply, there's no requirement for a site visit. COVID has taught us that contact is out and contactless is in. So once the data is captured, we make it simple and engaging through our experience design expertise. So this could be through an app. We also have a web portal. We also have an API through which the data can be integrated through to a home automation system, a building management system, a DERMS package, or even a CRM. And here in this example, you can see that the end user, be it residential or CNI, they can see their energy used, the direction of energy flow, what each appliance is consuming, and how much they're spending. It happens in real time, which allows for meaningful change, whether that's changing habits, appliances, or retail plans. And there's no need to wait for the bill to arrive. I think Indians, like Australians, always want to know what's going on when the match is going on. Providers, on the other hand, can see energy usage, generation, power quality, either individually on individual sites or in the aggregate. And this can happen either in a chart form, a tabular form, or in this kind of Google Maps of energy format as well. The power sensor is a product by DS. We've been digitizing distributed energy for 16 years. We've launched many Australian firsts, the first energy portals for the distributors, grid-connected EV chargers, in-home displays, and the power sensor is our latest product startup, one of 3 that we've launched. We feel the future for India and Australia is very bright in energy efficiency and engagement. Indians love jugaad, Aussies call that DIY, and we feel that there's great scope for engagement. We've identified a number of conversations this week that we're very keen to follow up on. Ours is a partner-led go-to-market business model, and we're very keen to hear from anyone who else is interested in these topics. Thank you very much.
Thank you, Sundar. So I want to open this up to the panelists for any questions that you may have. Arul, I see you've got a question.
Yeah, so one question is, what is the ROI on your investment for the existing customers?
So for an end user?
Yes.
Yes, so typically we find the savings can occur either through changing of habits, appliances, or retail energy plans. And typically we're seeing, through the Victorian Energy Policy Institute, they did a study over here. And even on the basis of small unit volumes, we're seeing the payback can occur, so they can save up to about 30% of their energy that they're consuming. If they've got solar, they can optimize their self-consumption. In Victoria, the average saving is about $1,100 per year. We feel that could be increased by 10 to 20% through optimization of self-consumption. And this is where, that holistic energy insights comes in. With the kinds of volumes that India offers, we can drive down our unit costs considerably. And we feel that, that payback period could be potentially in year.
Beautiful. Thank you, Arul. Any other
questions? You said?
Beg your pardon?
Go ahead.
Sorry, you're on mute.
You're muted, Arul.
I said, did you say payback period is within a year?
It can be potentially within the year, depending on the volumes and the electrical setup that they have, whether they have solar.
And in Australia, what is it today?
So in Australia, we can achieve within the year as well.
Okay, great, thank you.
Iman?
So one quick question from my side is this is basically a B2C that you're offering, or you're working with the distributors and providers?
Absolutely. So ours is a B2B2C model. So we will work with those that have the end customer connect. So this could be either appliance vendors, energy retailers, home automation companies. So like, for example, the Luminous business within Schneider, could be, your home automation business, Arul. It could be also working with distributors to uncover the energy insights on the distribution or LV network for standalone power systems. So there are a number of different business models that are all underpinned by the ability to capture data at a very, very low price point and at a very high level of convenience.
Okay, so if you're saying a yearly saving at least was around $1,100 in Australia, and people can actually have an ROI. So do you mean that the cost of the device is $1,100?
No. So the $1,100 figure was the average saving on the basis of a solar install. This is the power sensor itself.
Okay.
It's not. Yeah, here we go. So it's actually a very small device, and the typical cost in say for a solar package, which is 2 power sensors and a plug, would be retail. In Australia, we're going to market at $299 retail. Obviously, there'd be there's significant channel margin in there. In India, at very significant volumes, that can be driven significantly lower. So the average, to give you an idea, the average energy bill in Australia, based on CanStar data, is around 2,000 Australian dollars, and that's actually gone up during COVID. So we're within about 10 to 15% of that cost retail at low volumes, and so we feel that we can make a significant impact.
Okay, thanks.
Ritam, you've got one question as well.
Yeah, I heard you said you work with developers, power producers, and distributors. So, what kind of benefit or value improvement have been observed for them? Can you share some insights there?
Yep, absolutely. So, we are currently we have these are the kinds of data sources that we capture. That I don't know whether you can see the slides on screen still, but so we can capture power quality information. So we get a voltage reference from the household or site. We calculate a power factor as well and harmonic distortions. So we can actually get a lot of those power quality types of measurements. So the discussions we're having with the distributors today are to replace the expensive power quality monitors, particularly for fringe of grid sites. And in some parts of Australia, they literally have to put an engineer on a plane to buzz them out into the countryside with these very expensive power quality meters. With this, we could literally post it out to the household, and they can self-install it within 10 minutes.
Beautiful. Thank you, Sundar.
My pleasure.
And thank you for the panel for their questions. Next up, and finally, we've got Richard Mackinder from Edge Electrons. So Richard, if you could unmute yourself and share your video as well. The slides look good. Thank you. You're on mute, Richard.
How's that?
Sounds great.
Excellent. Hi, everybody. Great to be talking to you all, albeit in the graveyard shift here. Thanks, Abs. Edge Electrons. Edge provides real-time, end-to-end energy monitoring and data for the low-voltage distribution system and end commercial and residential customers. So everywhere from the substation to the home. The proprietary monitoring technology supports a platform for electricity networks that enables improvements in O&M management of the system. That real-time visibility allows for better response, disaster response, and improved network planning in the context of the disruption of generation of new technologies coming into the market. In the home, we have, and the business, we have patented hardware around voltage regulation and power factor correction for both residential and commercial customers. Sorry, I'm just trying to... referring to Manoj earlier this week, this is the biggest game in town over the next 25 years, but the transition needs to be an orderly one. Now, we're all familiar with the energy trilemma of the need to continue to supply affordable energy, sustain power quality, and tangible action on climate change. The fourth element to that we believe is we need to remove customer confusion. So that's where the real-time data, which we provide from the Edge Data Solutions, is critical because we put the customer first in all our solutions. The industry is transforming, as you know, from one where it's pretty complex and opaque for the customers with the current generation fleet, which really delivers a very poor service to the customers. By providing real-time data and data transparency to the customers, we're able to give customers better knowledge of their energy costs, and we're able to move them onto the optimal tariff. We identify for them what the best solar solution, the best battery solution, or the best solution is for their electric charging vehicles. The other aspect of our business from the customer side is that we partner with, we're not a B2C customer business, we partner with existing partners who have large customer bases where the addition of energy monitoring and the services we provide is complementary to the other products that they sell. And I'll talk a little bit more about that partnering strategy later. On a page, Edge is a business that serves both residential and commercial customers and electricity networks. We have patented hardware. The Edge eSensor transformer and grid monitoring fleet monitors transformers on the low voltage and medium voltage network and just pole top monitoring of power quality. And then at the residential level, we have a energy monitor for the home and the small business. And as I said, proprietary or patented voltage regulation and demand response control technology for the home and small business, as well as patented power factor correction for commercial users. This all supports a platform of data analytics, which we call the Edge Connected platform, which provides that real-time data visibility to our customers, whether they be residential, commercial customers, or electricity networks. The partners we currently work with here in Australia, Origin Energy, which is the largest retailer with exclusive power factor and monitoring supplier commercial areas, with Simply Energy, a subsidiary of Engie, we provide residential monitoring and voltage regulation for their solar customers. We're partnered with Price Waterhouse in providing commercial monitoring and power factor correction solutions to commercial customers in Australia, and with the Commonwealth Bank in a program to supply real-time energy monitoring for their mortgage customers. We also have traditional distribution channels through MIDIs, which is one of the largest electrical wholesale distributors in the country. And in the Philippines, where we have a manufacturing and engineering facility, we're partnered with the Department of Science and Technology and the Department of Energy in developing the Federal Energy Efficiency Regulation. And actually, our technology has been built into the National Building Code in the Philippines. With electricity networks, our major partners are in the Philippines, Meralco, the major utility network provider in Luzon, where we've just completed an 18-month trial program with 400 of our transformer monitoring units, and we'll be looking to deploy over 50,000 of those transformer monitoring units over the next 4 years. And in South Australia, where we've completed a similar size trial, and the program, they have actually over 50,000 transformers that will need monitoring in the South Australian grid. Internationally, we have partnerships with Utilligent, which is a large consulting company for networks utilities in the North American market, and with Vinci Industries, which is Asian, or Amexin, which is the Asian arm of Vinci Industries, a European utility provider. The team, myself, I was the Chief Executive of Energy Australia, one of the major 3 utilities in integrated utilities in Australia, and prior to that, Managing Director of the international business for China Light and Power. My partner and the founder, Neil Stewart, had a long and successful track record with Aztec, which was the essentially provided power supplies to Apple, built the Apple II computer, and subsequently sole sourced them for up to 25 million of those devices before providing IBM and Texas Instruments and others. So it's a combination of energy markets knowledge with electronics and engineering. One of our strategic investors is Flextronics, who provides us with that global manufacturing knowledge and supply chain experience. The business has raised over $20 million to date. Revenues in 2019 were over $6 million, and forecast $15 million revenues next year. The revenue model is one of annuity and data subscription model for our customers. We make a reasonable margin on hardware, but the principal focus is annuity and data subscription revenue model. And we're actually in the process of raising $7 million through a Series B financing to fund the international expansion of the business. Thank you.
Beautiful. Thank you, Richard. I want to open this up to the panel for some questions. So if you've got a question for Richard, please shout out.
Richard, since you have done some pilots, right, what is the value proposition for your customers? I think similar question I asked you.
Sure. So the value proposition changes a little bit of a customer. So with Meralco, the value proposition was really providing, they have very little visibility, very few smart meters out there. So they have very little visibility over their low voltage network. What we also found in terms of monitoring the transformers, you monitor where the constraint issues are, where the power quality issues are, so that they can do preventative O&M management as opposed to reactive. A couple of examples, there was a typhoon flew through Manila last week, 2 weeks ago, which actually put out the whole of the Luzon grid. Because we're monitoring real-time 30-second data packages, we were able to monitor how the network assets responded, which ones had the most, were subject to the early failure, and identified the weak spots through that. We did that similarly back in April when they had a heat wave at the beginning of the COVID lockdown, and we're able to identify those transformers on the network that were under strain because of the higher loads coming from people actually being at home during the day rather than in the centre of town. So it's power quality monitoring. The other thing that will be interesting in India is we've actually detected over 9% of non-technical losses, which is theft, on the grid, because by monitoring the transformers, we're also able to monitor points where people are hooking in and stealing from the grid. So I think that could certainly have a strong application in the Indian market. In Australia, it's more around, with South Australia, it's more around managing the network as it is struggling to accommodate the very high penetration, rapid penetration of solar and storage, and using the data that we're collecting to then provide a virtual model of what will happen as more storage and more solar and electric vehicles come into the market, and which assets will be under strain from. One particular example is a bus depot that's going into electric bus vehicles, and how that local transformers coming in.
So if I can ask, the data you're collecting is only the transformer data, or is there some other sensors that you are
we monitor we monitor the power quality through all of our monitors, and some of the monitors are just grid monitors, some of them are transformer monitors. The transformer monitors also monitor the performance of the transformer. They monitor the temperature of the oil, so you can then anticipate if you've got an overloaded transformer, higher internal temperatures there, you can actually work out what that's doing to the life cycle of the transformer. So we provide the transformer, the full transformer pad and pole mounted transformer monitoring, plus also just grid monitoring of the power quality at a pole top.
Well, we've got probably a minute for if anyone's got a quick question or comment. Richard? No? Excellent. So thank you, Richard. And we'll wrap up here. So I want to have a big thank you to the startups, as well as the panelists and their team for all the time, effort, and insights that you have provided, not only today, but during the week. So I'm sure the conversations will continue. This is just the beginning over the next weeks and months, and we're here to help keep that momentum going. And a big thank you to Global Victoria as well, to Michelle Wade, James Edwards, and Gopi Shankar for making this virtual trade mission happen. And thank you to everyone who joined us. And if you believe any of these startups could play a role in your organization or know of people they should meet, then please reach out to us. You can find their contact details on the Virtual Trade Mission website at in20.startupbootcamp.com.au. So stay safe, everyone. We'll see you very soon at the next Startup Bootcamp event. Thank you. Have a great day.
Thanks. Have a great day.
Thank you.
Thank you.